Hello students! In our previous video, we learned about physical properties of metals and non-metals and their reactions with different reagents like air, water, acids and other metal salts. From these reactions, we know that metals and non-metals form ionic compounds through ionic bonds. Now in today's video, we are going to explore how metals react with non-metals to form ionic compounds or ionic bonds. Let's explore first why do metals and non-metals react. Students, we know that elements react with each other because of their tendency to attain stable state. An element has a specific arrangement of electrons around its nucleus. The electrons are arranged in different orbits, and this arrangement of electrons is called electronic configuration of that element. For example, hydrogen, which is the first element, has one electron. So its electronic configuration is 1. That is, in first orbit, it has only one electron. Similarly, sodium metal has 11 electrons in its atom. So its electronic configuration is 2 electrons in first orbit, 8 electrons in second orbit, and 1 electron in the last orbit. That is 281 electrons in KLM shell respectively. Now students, you have already studied in your previous class that an element will be stable if its outermost orbit is completely filled with electrons. For example, outermost orbit of noble gases like helium, neon and argon are completely filled with electrons, that is 8 electrons, so they are stable. So we can say that for an element to become stable, it should have 8 electrons in its outermost orbit, with an exception of helium where it has 2 electrons in its outermost orbit and is still stable. Now the elements which do not have 8 electrons in their outermost orbit are unstable, and hence they take part in various chemical reactions to obtain the stable state electronic configuration called as octet configuration. In other words, such unstable elements react with other unstable elements and form compounds which are stable as compared to the individual element. In the process of forming compound, the element which gives the electrons develops a positive charge on it, while the element accepting the electron develops a negative charge on it. The whole purpose of this give and take process is to attain stability, that is, octet configuration. Students, again, the octet configuration is nothing but the stable state electronic configuration of 8 electrons in its outermost orbit or valence orbit. This octet configuration is also called as octet rule. Let us understand this in a better way. But before that, have a look on the table which is there on your screen. You can see that there are different elements like helium, neon, sodium, magnesium, nitrogen, oxygen, fluorine, etc. Each element has a specific arrangement of electrons in the orbits around the nucleus. For example, say helium has 2 electrons, so its first orbit K has 2 electrons. Magnesium has 12 electrons, so its first orbit K has 2 electrons. L, which is second orbit, has 8 and M has 2 electrons. Similarly, potassium, whose atomic number is 19, that is, it has 19 electrons, has an electronic configuration of 2881 respectively in K, L, M and N orbits. Now students, out of all these elements, observe elements like sodium, magnesium, aluminium, potassium, calcium, etc. They have either 1, 2 or 3 electrons in their outermost orbit or valence orbit. So, they can easily give up this 1, 2 or 3 electrons from their outermost orbit and attain the stable state configuration, that is, octet configuration. For example, if sodium, magnesium or aluminium gives up its 1, 2 and 3 electrons respectively, M shell becomes empty and the last but one shell, that is L shell, becomes the outermost shell and has octet configuration. And by doing so, these elements attain the stable state configuration. Similarly, potassium and calcium, if they lose their outermost electrons from N shell, their last but one shell M has 8 electrons and becomes stable. Students note, after giving up electrons, these elements become positive ions, as they have lost electrons, that is negative charges, but the positive charges in the nucleus is still the same. Now students, observe elements like nitrogen, oxygen, fluorine, etc. These are called nonmetals. They have 5, 6 or 7 electrons in their outermost orbit, and to achieve octet configuration, they accept electrons from the other metal atoms and become negative ions. So we can say that to achieve octet configuration, metals either lose their electrons and make their respective positive ions, or take electrons and form the respective negative ions. And the bond which is formed between these two ions due to the attraction force between these oppositely charged ions is called an ionic bond, since it is formed between ions. Students, this ionic bond is also known as electrovalent bond because it forms when the valence or outermost electrons of one atom are transferred to the other atom. Or in simple words, electrovalent bond is formed by exchange of valence electrons. And the compounds formed in this manner are called ionic compounds or electrovalent compounds. Can you tell me some examples of such ionic compounds or electrovalent compounds? Pause the video and think of some examples. Well, you try to find it out yourself, and we will see you in the next video.